Hello everyone. Good morning. Good morning, Gaurav.
Morning.
We have just 1 minute to go. Okay, so I think we can start. Hello everyone. Thank you for joining us this morning. I hope you all are doing great and I hope you're staying safe as well. I am Shivani. I work as a marketing specialist at Coditas and I will be your host for this session. Today we have Gaurav Ghate as the speaker for this webinar. Let me quickly introduce him. So, starting his professional journey as a Java developer, Gaurav co founded Aphelia with a goal to provide simplistic solutions for mobile applications. In 2015, he marked the onset of his second venture, Be Limitless, a product that helped people be more productive at work. In 2018, Gaurav joined Coditas, where he moved beyond mobile apps to providing full stack solutions in React and Node. He works extensively on bringing old products into next gen technologies like MERNStack. Currently, Gaurav is the Director of Technology for DevOps Services and also a partner in the company. Finding long term sustainable solutions to problems is the mantra he lives by personally as well as professionally. That was all about Gaurav. Now, a quick reminder before we get started. If you have any questions during the presentation, please put them in the chat box and we will be taking up the questions at the end of two sections. Over to you, Gaurav.
Thanks, Shivani. I hope everyone's doing well. And so, before I start with my uh, presentation for how to become uh, a DevOps engineer in 2021, I'll just talk about my brief journey with DevOps and how I have reached to the place where I am now. I started with DevOps. Actually, back then it wasn't DevOps; it was more or less server management back in 2010. And we used to do mobile applications back then. And I used to love handling servers, making sure that the backend for these mobile apps was stable, making sure that everything is in place so that the front end, which is the mobile app, works perfectly. And that's where I started getting involved in DevOps. Slowly, it became a part of providing end-to-end solutions throughout my career. At Coditas now, we have a full-fledged DevOps team, a DevOps practice. We make sure that we follow basic DevOps principles throughout all our products, and that's where we are able to give really quality products. And so just to start with what is DevOps. I guess most of you guys will already and girls will already know what DevOps is and where it originates from. So what used to happen earlier on was there were two completely segregated environments and segregated uh, people together who were working on the development side and on for server maintenance, server management, making sure that whatever the developers built was shown to the outside world. And pre-agile adoption, which has happened majorly over the last few years, but before that it was like the developers used to develop maybe for 3 months, 6 months at a time, and then suddenly they used to go to the operations guys saying, okay, now we need to deploy this. And then there used to be a huge cycle of builds getting failed, a lot of issues happening on that end. with Agile coming in and the industry actually adopting Agile over the last 10 years or so, I think everyone nowadays practices some part of Agile, even in smaller companies to even in bigger companies. And what happened was Agile needed this way of showcasing stuff pretty early. And that's where DevOps stepped in. Every Agile sprint or every Agile team started having a DevOps member, and DevOps is nothing but development and operations married together and living together and making sure that they don't fight in the end. That is the major thing which most of the DevOps engineers try to solve from time and again. And there are 7 to 8 different parts of adopting the DevOps technology or DevOps practice per se. Uh, Let me walk you through those as well. One is continuous deployment. This is when you check in the code, you make sure that the code, once checked in uh, to your repository, gets deployed from time and again in a very structured manner or in a very process-driven manner on 2 different environments. There's continuous testing, wherein automated testing scripts are a part of your deployment. Uh, then there is continuous integration and deployment. This means that uh, at times what happens is you're building the front end, some other team is building the back end, and then at times you need to make sure that the whole thing together integrated works really well. And that's where continuous integration and deployment of the same comes into place. And this again becomes a important factor in building the DevOps practice throughout your products or your services as well. And monitoring also is another angle to DevOps. I'll be talking about tools and etc. In the presentation later on. But monitoring per se becomes a really important factor because, as all of us know, or most of you who have worked in teams which have DevOps people, they're kind of the front end soldiers who are always working there to see whenever something goes wrong. And for that, in order to make sure that that works well, the monitoring becomes an important factor in building a whole DevOps practice. Now, DevOps as such, I would say, is not a technology. Is not. It is. I wouldn't qualify it as a technology. I wouldn't qualify it as something which would probably mean like Java or I'm a Java engineer, so I'm sticking to Java, or a React engineer who is sticking to React. DevOps actually is more from a culture perspective. It's more from a practice. I call it as a practice because it is kind of you need to keep on practicing it in your organization to improve on it. Uh, Adopting to DevOps definitely brings about a lot of change in your organization. And few of the really good factors that change in your company, which I've seen happening at Coditas, I've seen happening at different clients at which we work in also, uh, are our quality improvement is a definite. Basically, what happens is when you adopt to DevOps, you adopt to having unit tests as a part of your pipeline. I'll be talking about pipelines later on, but generally speaking, when you're deploying a in any of your environments, you can have checks to have unit tests run first. You can have checks in terms of different kind of linting also. This happened actually almost a week or two ago. Unless until I've seen this, and this happens even in our general case as well, unless until there is a governance or a government who tells you to do something in a certain way, people tend to avoid it. People tend to even go around it at times. But with DevOps, once you adopt it as a culture, that becomes slightly less possible, because you have the systems themselves telling you that, okay, this is where you're going wrong, you need to correct this. And an example which I would give was, I'm currently architecting a front end for a company as well. And there, what had happened was, we the DevOps, initially their DevOps practice didn't have any linting feature put in. Linting is basically checking your code, front end code or a back end code, for specific best practices, like have you removed all the unused variables? Have you made sure that unnecessarily you have an extra comma or something like that happens? Linting always helps you escape all those. And the DevOps, initially the team had said, because we wanted to get into a faster deliverable cycle, we wanted to deliver really fast because there were very strict deadlines, they had ignored this linting. And once their practice head came back saying that, why are you not doing this, they put that in. And then we had to struggle it out for almost a couple of days to get our linting into back into place, and the pipelines and the builds again started working well. So this happens from time to time, I'm seeing. And linting basically improves your quality of code again. Unit testing or end-to-end automation testing, all these lead to basic quality improvement in the whole products that you're developing for your companies or for anyone else. The second, as I said, discipline also comes as a part of adopting to DevOps culture. You need to, you're defining a process when you are adopting DevOps. You will have to have a certain, I mean, usually this is done by architects, but anyone can think of how their DevOps cycle would be like. So once someone checks in their code, what all needs to be run through, what all needs to be checked at, linting, unit testing. Once that is built, how do you build it up in terms of what kind of artifacts are you going to build? How are you going to push these artifacts into different environments? All these things, you set a standard way of working in it. And once you do that, initially, I've seen teams who are adopting to DevOps as a practice first time, they do struggle it out a bit initially, but eventually what happens is it becomes so seamless that people, if start missing out on the day-to-day hindrances that they had earlier on, of this is not working on the server and so on and so forth, that these problems come down really fast. Next, three things that add to the advantage from a company's culture's perspective is, people end up starting to get to know that they've failed in something quickly. So faster to fail is something which I love. It comes from agile practices itself, but with DevOps, that it helps you multiply that. And since you have a certain practice or a certain development cycle, what happens is, the sooner you fail, the feedback comes back to you, and then you can quickly make changes and release. So faster to release also comes with it, and then faster to market also. So all three of these things come together and make sure that your product becomes robust and it's faster to get to the market as well. And so most of the DevOps cycles are based on automation. And what happens is, it helps you get less human errors in there. It helps you bring out more errors at a level which mostly developers fail to cover up. And hence, it kind of helps the whole quality improve and makes a really good change to your culture. And a very good example, I was working with this client last year, and they had releases which were almost like once per month or so. And they had different issues. Mainly, they were more from the. It was a more legacy product which had to have releases after a month, because that if something you made a change somewhere, something else would start breaking, and that was the main reason they kind of adopted to this new stack for development also. And parallelly, while doing that, they made improvements in their DevOps culture, they made improvements in how they're going to deploy, they made improvements in all places. And remarkably, what has happened is, now in the last year or so, they were able to make over 300 releases. Their clients were initially complaining as to why it's so slow in getting a bug fix out. So even a bug fix would take 15 days to show up on either of their environments. And to in order to with adopting just few practices, they were able to really change their client's perspective also, in terms of how they're adopting and making sure that these changes are going faster. So I had seen this movie from Who Am I from Jackie Chan, and whenever I'm talking to my team, or whenever I'm talking to taking a DevOps engineer's interview, I always kind of get back to that this thing. As a DevOps person, you play multiple roles. If I, if you have learned object-oriented programming, polymorphism is the best example of how a DevOps engineer works. Today morning, you might be writing something, some piece of code to make a new infra structure up for a particular client. In the afternoon, you might be, debugging through your monitoring systems to see why certain things are failing. In the evening, you might be launching a whole new environment, or helping out, or probably dockerizing a new application, or a new microservice. So it you play multiple roles just in a single day. And as in if you ask me, if from a now in 2021, what who is a DevOps engineer, I would say it is a combination of someone who is into cloud, someone who is into a completely knows at least one of the clouds, someone who is into site reliability and monitoring. So they're the since DevOps are the people, DevOps engineers are the first point of contact in a lot of places wherein failures happen. They are the ones to even get up at night and make sure that the infra is correct, so that the show must go on. And thirdly, you also do a lot of automation and programming. So there are few tasks in the DevOps practice which over the time are quite similar, but once you automate them, once you write programs to make sure that they happen in a certain sequence, you can always improve on them. And so programming and automation kind of come also a part of being a DevOps engineer. So that kind of gets us to our main agenda for the webinar. It is more from a perspective of, when you say what all do you need to cover when you are becoming a DevOps engineer in 2021. The list which I've shown here is a very high level thing. So I mean, no one initially expects you to know all of these things, but eventually, if you want to really outshine as a DevOps engineer, you should have concepts for all of these together. There are I will walk through each of them one by one in the next few slides. A few things probably already you might know, you might have worked on earlier on. You might be coming from a different stream altogether. So you may be a test engineer, or you may be a software engineer also. So based on wherever you come from, there are a few extra things that you need to learn as a DevOps engineer. And let me walk you through each one of them. Let me start with the first uh, part of what you need to know of while becoming a DevOps engineer in 2021. Basic concepts of software development. So you should be thorough in the software development lifecycle. So as as a DevOps engineer, you need to know at which phase of software development lifecycle comes what. So theoretically, all of us at some point in our careers, or at some point in our college life as well, have learned about this software development lifecycle. But as a DevOps engineer, you day in and day out make sure that that lifecycle becomes automated. So you need to know how or what kind of language the developers are using, what how do they work particularly in terms of when they're working on their local system, what all do they use, how they build their local project up, what do they use in the front end, the back end, the database. These days, earlier on front end side, it was pretty simple. You could just have a HTML, CSS, and a JavaScript. Go to /htdocs on your Apache folder, which you have installed on your server anywhere, or you could just uh, find a hosting somewhere with an admin interface, and then you just had to deploy these files there, and that was it. It was done with that. But these days, with the amount of new types of technologies that are coming in all the front end side as well, it has become you need to learn a lot more. For example, with React, how do you build it up, or with Angular, how do you build build it up, how do you host it. In fact, simple things I learned while deploying React applications when I was doing a few at Coditas itself, was if you need to deploy a React application at a folder inside your domain. So say xyzdomain.com/Gaurav is where I want to deploy a React application. I need to make changes in the package.json, which is governing the whole build for that particular React application. So stuff like this, probably you will learn from your experience, but at least you should be aware of what all are your developers working with. So you will be given a task of hosting this project, and that project might have, as I said, the front end, the back end would be another technology. It can be Node.js, it can be Java, it can be .NET, and all of these nowadays have become even more complicated uh, with the thought of packaging them as microservices. You need to be well versed with how do microservices work, what is the pattern in which they communicate with each other, how do you make sure that one microservice talks to another, which talks to the database, which database does it talk to. What in fact We had a project in Coditas which had the same front end talking to different microservices, talking to different types of databases also. So there was a Mongo database which kept in transactional data, and there was a PostgreSQL database which kept the more structured type of data. And we had to make sure as a DevOps engineer that all these communicate well as they're available for any consumption from the front end or from the API. Second thing, which from a software development perspective, which you need to make sure you know, is what kind of versioning are the developers using. So here I mentioned that which Git flow are they using, but it can be, I doubt, but there might be people still using Subversion or SVN, which used to use a lot back in 2010, 28, 2008 and 2010 around. But nowadays, most of us use Git. Git is a very Git is a really good system to have. I'll be talking in more details about versioning on that side. But you need to know what steps are the developers taking to check in their code. So stuff like which is the branch which is stable. Usually, when you, in fact, later on as architects from a DevOps perspective, you will be defining the Git flow strategy for any particular project. So, but if you're starting, you just need to know, as in, okay, as a developer, this person is making sure that he or she checks in their code in the develop branch, and the develop branch is kept stable. That is what needs to be known from a DevOps engineer perspective in order to build further automations on top of that. Other parts are, maybe sometimes what happens is there are applications which are configured on the local system which make things work. We had a really weird issue recently with another React application, wherein it was working with, if you have ever worked on React Redux, there is a Redux dev tool which helps you, debug the Redux side of it. And what was happening was, when the React application was working, it was working fine when the dev tools were on. When once you shut it off, it stopped working. So, in the solution kind of was quite different. It was not related to DevOps, but when a lot of things happen and work well from an engineer's perspective. So from a software engineer, you might get the code. He will definitely stamp it, and I'll mention this again later on also, but stamping, saying that, okay, it works now. But in a lot of times in the actual environments, there will be glitches, mainly due to some packages missing, some unmatched, something globally installed on the developer system which is not present on the server, and so on and so forth. So you kind of need to be aware of how the software is developed that you're going to deploy. The last part of, from a SDLC perspective or a software development lifecycle perspective, that you need to really know is automated testing. You don't need to write automated testing. You don't need to know how they work or actually program automated testing. But you definitely need to know as to how, from a command line, can you trigger the automated testing suite, and where is the output. In a lot of cases nowadays, in order to improve the quality, we do that at Coditas, at a lot of projects. We make sure that all these test cases, when they pass, they have to pass, and there is a sufficient amount of coverage. So with unit test cases, it is usually kept to 80-90%, added with automation test suites. As long as most of the tests are running fine, we don't raise any flags. But if there is something failing, that's when you immediately raise flags. And for that too, you can write triggers in whatever communication mechanism that you're using. So that comes as a second part. But basics of automation testing as to how do you run a test suite, or what is a test suite? How do you make sure that what is the, again, it is kind of tied to the technology which the developers have put in, but you should at least be aware of how these things work. The second part of being a good DevOps engineer or learning to be a good DevOps engineer is knowing operating systems. I wouldn't say very thoroughly. There are at least, I mean, but you need to really know how to, modify or make sure that how do you basically have different servers set up for the application. And for that, Linux is a good option to start with. There are still a lot of Windows servers which are being used with even Azure as the cloud platform, and with AWS and other cloud platforms as well. They're mainly used in places wherein you have to have compliances, mainly because Windows is quite easy to make it compliant with other tech in terms of security measures, and from that perspective. But with Linux, you get more power, because there is a lot of stuff which helps you learn and get things done on Linux as well. From as a DevOps engineer, you would definitely need to know how basic shell command works, maybe with PowerShell or with the Bash shell also. Simple things like how do you write a regular expression for modifying stuff? How do you write, make sure that, if you want to encrypt something, what do you use to which is readily available in Linux? How do you make sure that simple things like how do you find stuff on a Linux server? Usually, if you're very well, if you've been using Windows for a long time, it kind of is a higher learning curve, because Linux is more based on command line. But it you need to be very comfortable with command line. I think that is the next slide that I have. But basically, everything that you need to host your application inside a server, it needs to be you need to be well versed on that front. And with that comes, how do you install different softwares on your server as well? So basic stuff like apt-get, and you shouldn't struggle when you're on a server, and you should be able to quickly make sure that things are getting deployed, make sure that the correct build is there. All these things will happen only if you're very comfortable in basic Linux commands. And I wouldn't say you need to even go to a having a server administrator, Linux server administrator certification or something of that sort. But as long as you're comfortable in finding the root cause with a terminal given to you, you would be self-sufficient on your own. And that's one of the prerequisites nowadays that is required, because a lot of servers are use Linux. Another thing which a lot of DevOps people I've seen don't pick up initially, but eventually end up picking, is a good language like Python or Go. Go is more recent, but Python-based learning Python kind of gives you an edge over other DevOps engineers in terms of automating stuff, and you can easily write, a combination of a few Bash shell commands plus Python helps you build really good automated deployment scripts on your own as well, in case you're not using any other tool for doing the same. So as I said, mainly you should be happy with seeing such interfaces. I love having interfaces like these on my end. Recently I've been working on a Windows system, but so far I've been a pro Linux, pro Mac guy completely, and I love SSH or tunneling SSH through SSH into any server, finding out if things are in place, and it gives a different kind of thrill when you go through the command line as well. The other part of so this kind of gets us to the third point in becoming a good DevOps engineer in 2021: networking and security. So let me first talk about networking because security, I'll give an overview, but it's a huge topic as well. So with respect to networking, and if you see so far, if you read through a lot of cloud engineering or a lot of blogs which are related to DevOps, I see people going the other route. So learning probably AWS or GCP or one of the cloud, or trying their hands on the cloud before understanding all these three factors that are there. So that is why the sequence which I've kept this is more from a perspective of making you into a fully what do you say, configured DevOps engineer. So networking, so bash scripting, networking, security, and basics of software development, I think you should definitely learn them first and then get onto a cloud, uh, get onto learning for a cloud. So networking, in that you need to, whenever you're building a cloud, building a application on the cloud, nowadays everything is kept under private networks. You build everything because security is a major concern. You need to know a lot from a networking angle. How do you block ports? What are cider blocks? How do you define what is okay to access? How do you define ingress and outgress control, which is more like what is allowed inside, what is going out? And most of the interfaces or most of the servers that are used for developing these um, or deploying these softwares already have all this in a certain way configured. So you need to be you know knowing at least how to get stuff outside to the public, and what all is to be shown to the public and what all is to be hidden, and how do you hide it from a networking perspective. The all of us had at least I had this computer networks as a subject in my college, but definitely a browse through of all that when you are starting on your DevOps journey makes sense, because you will be dealing with all of that. And then if you get there and then start realizing, okay, I don't know what cider blocks are for, or I don't know what a static IP is, then you will need to again come back. So rather than going ahead and coming back, I would say first get these concepts clear, then you can go ahead. Security nowadays have become at most important. Uh, in fact, if you can see the unfortunately the text would be slightly blurred, but we had this issue recently in one of our projects. We had just spun up a cluster for our dev environment for one of our clients. We were just doing some small POC for them, and what happened was we had made sure everything is secure in terms of the passwords, the server passwords, everything else was kept secure, except for testing purposes. The developer, I think, for maybe overnight, just kept the server accessible to public in terms of probably in terms of just accessing basic stuff, because they were trying to do a POC. And what happened was, the next day when we entered the server, or logged into the server again, we had this message saying that pay us 0.15 bitcoins. So fortunately, this was a dev environment, and we don't ever do this on a public, uh, uh, stage, or never do it on a higher environment at all. But what happens is, you need to be extra careful when you are giving access to public nowadays. There are a lot of hackers, there are a lot of people around who are ready with sniffers, ready with password breakers, and everything that you have to attack your system. So with great power comes great responsibility. It's a Spidey quote, but that definitely is. You need to keep that in mind from a security perspective when you're starting your DevOps journey ahead. And so, also talking about security, the main other aspects which even most of the cloud providers follow is give minimum and gain maximum. So you have to make sure that all your resources under your when you're exposing something to the public, only probably the front end is what the public can access to, but rest everything, the database, the backend, everything should be very tightly controlled with access controls. With you can have API gateways to make sure that there is a huge amount of work, as well as dollars that are put in to make sure that all products are secure. In fact, we at Coditas also do a internal audit for almost all of our projects to make sure that they're kind of at least to a base level security compliant. There is a there are guidelines called OWASP guidelines, which are really useful in terms of at least seeing where vulnerabilities are from your infrastructure point of view for any given product. And it can be as simple as your text field is allowing you to enter SQL. So that's a really uh, miss from the developers end and from the infra end. But you need to know these basics as well when you're starting a DevOps journey on your end. So I would like to uh, take a few minutes to take in any questions that are there. Uh,
Sure, Gaurav. That was one interesting session. Let us take a few questions from the audience and then we can move to the next. So we have
sure.
first question from Premanand. The question is, what prerequisite requires to excel in DevOps?
I would say probably all the things I've listed down here. So if you need to excel, definitely this set of all the points which I've covered here. At least if you are good at say 2% in each, then you should easily excel in DevOps.
All right, yeah. So there's next question from Nikhil. Nikhil asks, how does a person with 6+ years of experience change his or her working domain from non-DevOps domain? For example, ETL or finance to DevOps or cloud ops.
Okay, that's a good question. So, even in my perspective, I was never into DevOps. I'm still playing a dual role of being a programmer and managing operating systems and stuff. Uh, Ideally, you need to spend more. Ideally, you just need to take out time to learn a few things, DevOps is relatively easier as compared to learning full-fledged programming. There are a lot of DevOps related activities which may not involve programming as well. Once, for example, in a lot of bigger companies, what happens is once the infrastructure is set up, it's more from a monitoring perspective or from a uh, you know feature based deployment perspective that you get involved in. Ideally, make sure you gain a bit of knowledge. You can in fact uh, uh, take a small if you have a laptop at home, start digging in terms of dual booting it. Stuff like this helps you understand basic operating systems, basic things against what we would need, and then eventually and I'll cover that in the later on slides also, learn about cloud, learn about orchestration, learn about containerization also. But I would say follow start with smaller things, start with experimenting on your own, trying to find out so my journey, in fact, when I was in college also, I used to really love opening up my system, taking out the hard drive, I've crashed a lot of hard drives, I've crashed a lot of servers as well. So but then that curiosity and interest needs to come from within you, and once you start doing that, then DevOps becomes exciting because it's all related to making sure stuff works and how it works later on.
Right. Okay. So, Gaurav, I think we can move to the next section and we can take further questions towards the end.
Sure.
Yeah.
Thanks.
Thank you.
So yeah, that gets me back to the other side of DevOps. Now we'll get into more of the in things, I would say. So whenever you search for DevOps nowadays, all the rest of the slides that come in will you'll definitely get references to them. But so let me start with containerization and my story with containerization. So what had happened was this was when I had just joined in Coditas, and we were building an application for a finance company, and we had structured it in a beautiful way with microservices and everything. And back then I didn't know containerization, and I was the lead on the project, and I knew that if I need and they needed to see you know frequent updates on where we are, how are we progressing, and stuff like that. And they had assumed that we knew what we are doing and everything. And that's when I realized if I need to deploy, there was 10 different services. So consider it as if 10 different applications needed to be installed and up for even a single demo. And if I would have done it with the older way of we had written them in Node.js, and I knew there was a way of running multiple Node.js programs with a simple tool called PM2 on any server. But then uh, I was quite scared in terms of what will happen if one goes down. How would I manage all these things? And that's when I realized and started digging deep, and that's when I got my hands dirty in Docker. I started loving it. I still love it, the way it works. And the good part was it. Eventually, I was able to deploy everything within 30 minutes. So 10 services used to get deployed. Like if you needed to deploy the whole application together, it wouldn't require more than 30 minutes. And everything was in a single file. So you just needed to run one script and it would run the whole thing together. And couldn't have done it without Docker. And Docker comes, so Docker is a tool which allows you to do containerization. Docker doesn't mean it is containerization. It's just a tool which helps you do containerization. What containerization is actually you are boxing everything together. It's like probably what Amazon does with your parcels. So okay, this is for Gaurav, this is for Chandan, this is for Shivani, and then inside that parcel, whatever is there, it is for Gaurav, or it is for Chandan, or it is for Shivani. And so it's like building a small environment inside whichever server or wherever you want to deploy it. And so the thought behind it is came from virtualization. So virtualization was something which was started and in fact virtualization, I would say, is what has led to the cloud, the booming of the cloud, because initially what used to happen was there were servers, and division of the server space wasn't that well done. I remember people used to spend a lakh or two just to procure a server and to host a few websites. And it was back then that there wasn't any other choice to it. But that's when Amazon stepped in, and now they're in a different league altogether. But that virtualization happened at the server level, and then there was another virtualization and encapsulation which happened at the smaller level also. And with Docker, what happens is you end up building small environments inside your system, and with minimum and these are very easily configurable also. I've used Moodle. I've done hosting for a lot of PHP based applications earlier on in my career, and even at Coditas we needed a Moodle server for some tests that we wanted to conduct. And what happened was, earlier on I used to pick up an EC2 server, install Moodle, install PHP, make sure MySQL is there, then somehow connect it. And all this used to take around 6 to 7 hours just to get it up. But post Docker, I just needed to run one file, because what it did was it created a small container for MySQL. It created a small container which had Apache. Apache is used to host PHP. And so these there are images now available for all these softwares or all these basic tools that you need. And this is then installed inside this container. So the once you install the Moodle container, it will automatically build up the whole PHP site that is required, and connect the only thing left was for me to figure out was connecting it and then publicly exposing it. So it took me around 2-3 hours to just get that up. And so and Docker is beautiful in terms of nullifying this. If you see this emoji over here, it works on my system. That is something which used to irritate a lot from for any DevOps engineer or anyone related to server management, because it works on my system now is totally nullified. Reason being, you can build and deploy the same Docker image on your system and check it out as well. And a lot of times when that happens, you realize, okay, there is some configuration problem, there's some parameters which I have hard coded, and that's why it's working on my system and not on the server. And this with Docker and different types of containerization techniques, this has reduced a lot of issues which come up post deployment as well. And so Docker, or picking up Docker, or any type of containerization, understanding how containerization works, what are container images, how do you give so with containers, what happens is you have to give them specific amount of RAM, specific amount of hard disk space also, and all that can be controlled further as well. And to do that, gives you a lot of power as well, and hence learning containerization is definitely to do if you're planning to get into DevOps now in this age. And finally, we come up to the point wherein you people usually start with. So cloud is something wherein it's kind of the endpoint towards which you are deploying stuff to. Before that, even in cloud, whatever I've covered so far, you will be using all of those things, and then the final thing, where do you host it, is usually on the cloud. So me how much part is knowing just cloud and cloud services as a DevOps engineer in 2021 is important. I would just give you 30% or so. 70% comes in more how do you configure it, how do you make sure it how do you configure the network inside it, how do you configure the virtual private cloud inside it, how do you configure different services together and make it secure. That whole packaged together makes you a DevOps engineer nowadays. At Coditas, we have worked with, we've been fortunate to work with, in fact, all four clouds. People who haven't heard about Ali Cloud, there is an Ali Cloud which is used across China and Indonesia and that part also. We have a client which hosts stuff there. Azure, for enterprise application, Azure is still one of the leaders. We are we have a couple of our applications running on Azure. With AWS and GCP, we have a lot of our applications there. Google, AWS has always been in the forefront. They were the first adopters in a lot of spaces, and hence are still preferred as a go-to cloud by a lot of startups and a lot of people as well. Google Cloud, I would say from a learner's perspective, is great because they provide a lot of free credits. You can do tremendous amount of experimenting with Google Cloud. In fact, set up servers, destroy them, hack into them, do a lot of experiments first with Google Cloud, then. And services wise, I would say AWS is far ahead. They are getting, and the amount of new services that they get in every year is phenomenal. But all of them at the base level have the same things there. If you take a EC2 is nothing but a elastic cloud compute, is what is the EC2 is the short form for that. But what it is a virtual server, and the same thing is called as a virtual machine on the Google Cloud. I'm not too sure on Azure because I haven't worked on it, but it's kind of the same language that goes through. The only difference is the way it is configured, the way the console is, the way the commands are, the way you access towards it. That differs, but at the base level, it is a definite that all clouds use the same terminology, request you to follow the same methodology. Like I said when I was talking about security, uh, all whenever you generate any infrastructure resource on any of the cloud, the amount of access that you are given is bare minimum. It will be like then you will initially need to struggle it out to make sure you get access to it even on your local system as well. So uh, that is, and that happens, that is the same case on Google Cloud, AWS, or Azure, or any other cloud as well. So principally speaking, I would say pick up one of the clouds. either of them initially. Go for a certification if possible. It improves your knowledge, it improves your perspective towards thinking, it improves how you uh, especially the solutions architect associate exam from AWS, which I cleared a couple of years ago. That kind of changes your whole perspective towards making highly available, highly resilient infrastructures as well. And once you learn that, applying those same principles across rest of the clouds become very easy. So I am a very pro certificate guy. Definitely, it's good to improve your knowledge, and it is also a way, to getting to know to what depth have you uh, learned about the cloud or learned about certain services in the cloud as well. Is more from a cloud perspective. I will not get into comparing clouds and this thing, because for me all of them are same. And I merely wanted to specify that yeah, get certified, get spend time in learning, and that will definitely help you kickstart your DevOps journey also. Uh, Kubernetes is a different. In this, I've kind of, in the essence of time as well as making sure that everything is together, I've pushed in Kubernetes in here. Kubernetes is nothing but a container orchestration tool, very widely used. It was originally built with Google Cloud, but has its own presence and can it is more like a framework for container orchestration. What do you mean by container orchestration? If I go to my previous slide, containers are nothing but small services that you build, and orchestration of these. So how do you communicate within each other with Kubernetes? So let me take two steps back and explain how Kubernetes came into place, and how containerization has made it even easier to have highly available sites as well as applications. So recently, if you were trying to register to Arogya Setu, I doubt if they're using that level of highly availability that can be given with simple basic things. But what happens with containerization is you deploy these in small nodes, or uh, think of this as you're popping up different nodes per service that you have, and due to some reason one node goes down. uh, with Kubernetes, and there are other container orchestration tools like OpenShift, and there is Docker Swarm. Then there are many tools which do this, but Kubernetes is most widely used. There are certain commands and certain ways of orchestrating and defining simple files which allow you to tell the whole cluster of these nodes that, okay, if these go down, bring 10 more up, or if this goes down, bring 5 more up. If this goes down, trigger a health check issue, trigger a notification which goes on your Slack or anywhere else. So that, and also how do you control ingress outgress again to the whole cluster of containers that you have to run the whole application. So all this is kind of governed and made easy with Kubernetes. You need to know or be well versed with how Docker works generally before you get onto Kubernetes. But that knowing, at least having basic knowledge of Kubernetes, will help you definitely on your journey to become a good DevOps engineer. And the other side, which is now becoming which is also very widely used, is serverless. So initially, like I said, all AWS, Google Cloud, and everyone uses virtual servers nowadays. But what AWS introduced a few years ago was serverless. This allowed you to write a piece of code and not worry about how which servers do you put in and where do you host it and how do you make sure that it automatically scales. So AWS has services which help you out on automatic scaling also, but serverless is the epitome of making sure that stuff works at a very large scale as well. The only in terms of knowing about serverless, yes, even Google now has all cloud providers nowadays have what do you call these functions, or in AWS it's Lambda functions. In cloud, it's I think Firebase functions, which allow you to do simple things as well as complex things. Recently, we used a Lambda function to make sure that on the same website we needed to or on the same domain we needed to get the final storage where the site was hosted. So depending on which flavor of the cloud you're using, you should at least know how serverless works. How do you configure an API with serverless? How do you host static sites in Google Cloud? How do you host static sites in AWS? Some basic fundamentals are definite, and these can be, like I said, with both AWS and Google Cloud. They give a lot of freebies. There are a lot of other platforms also, like WizLabs, like Linux now it's called A Cloud Guru, wherein you can, though A Cloud Guru is paid, and WizLabs also is paid, but with webinars and other places you do get credits for these. And what these providers do is they give you playgrounds as well for these clouds. So in order to do certain experimentation, rather than going directly to the cloud, I would suggest first try it on WizLabs and other places. uh, and one more thing is, be very careful with the infra that you build on the cloud, unless and until you have sufficient knowledge of what is the difference between the scale of the server that you're building up. Do not build on your own cloud. I've seen this happen. I have written a lot of mails to AWS and Google Cloud telling them that, okay, this was due to a trainee, please remove it, and please spare us the charges that you have put in. But a lot of time what happens is, when you're first time trying to experiment, you end up selecting maybe a large system on your cloud. And on these cloud, all these clouds, what happens is you're charged by the amount that or by the consumption. So if you keep it on for 24 hours, you might get a huge credit card bill. And all these clouds require some kind of credit card or some authentication earlier on to make sure that that is happening. So make sure that you are well versed with at least these sizes before you get on to actual experimentation. Yeah, that brings us to another side of DevOps nowadays: continuous integration, continuous deployment, and version control. So a definite must have as a DevOps engineer nowadays is good knowledge about Git. Git is nothing but a version control system. GitHub and GitLab and Bitbucket are nothing but softwares which use Git internally. So Git is kind of a framework, I would say, or uh, the way you run few commands to make sure that your objects are under version control. Uh, a definite must read for everyone to know about how Git works, how once you push the code onto your version control system, which is GitHub, where does it go? How do you branch out from the current master? How do you make sure that uh, on the branch, how do you check into the branch? Basic branching for with Git, you need to be well versed with that, because that kind of becomes an input to your tool, which is going to do the continuous deployment or integration. One such tool, I think, which is a definite must to have basic knowledge on, is Jenkins. There are nowadays both GitHub with their GitHub Actions and GitLab with their GitLab CLI, CI, CD also help you do this automation for integration and deployment. But Jenkins is something which is basic. It is you can host it on your systems. You can make sure that it is you can play around with it. And with Jenkins, what happens is even though you're not a plumber, you will be playing with pipelines. So everything in Jenkins is testing and making sure that based on so it's like you kind of have a workflow at this stage. Do when I was talking at the starting that you define the workflow. So Jenkins takes care of executing it. So uh, when do you push the automation test or trigger the automation tests? When do you deploy it? When do you clear the cache in your deployment? When do you make sure that it is if you have a visual regression suite, when do you run that? And post that you get, so with all Jenkins this thing, you have a console, you get nowadays you get all tick marks also done against a build cycle. And once you have them through, uh, it it feels good when you get all green ticks on your Jenkins pipeline, and then you take that forward. Yeah, that brings me to so just earlier on with Jenkins. Sorry, earlier on, infrastructure as a code wasn't too much of a requirement. Even right now, if you're starting at DevOps, don't think more about this. This is more from an information side of it. But nowadays, especially with the amount of the bigger the clients, the more importance is given to this. And since at Coditas, for us, code is art. That's why even with infrastructure, we do love writing code against it. And this gives us two most important tools which you can dig your hands in for infrastructure as a code is Terraform and Ansible. Both of them have similarities but are used slightly differently. Terraform is mainly used from infrastructure provisioning point of view. It so what is infrastructure provisioning is usually when you're working on an application, you deploy it in different stages. So you have a dev environment wherein the devs can play around whatever they deploy. They can see, they can fix. Then there is a QA environment wherein the QA guys come in, they do some manual testing, they do some automation testing. And the reason it's different is because automation scripts can help. Sorry about that. Automation scripts can help you run stuff faster on a separate environment. Then there is staging environment, which is used for user acceptance testing. Usually, it's the client or the BAs or someone from the client team who checks out stuff on the user UAT environment. And finally comes the production environment, wherein with utmost security, but a public facing side of the product is shown. So usually, and what happens is, when you start the development, initially you just need one environment. Say probably if you're using a containered approach, one Kubernetes cluster with maybe a few nodes is fine for your dev environment. But as you go ahead, this whole complexity of the infrastructure itself increases. And to avoid, uh, there is a way of manually creating that for the next environment. Say I'm now requiring a QA environment, and I want to build that up. uh, you can do that manually, but then you'll spend 2-3 days of your effort to get that done. So with Terraform, what happens is you actually write code to do this, to define the infrastructure itself. That okay, I need this, so many EC2s. So one S3, one RDS. RDS is nothing but database. If I'm taking a very simple example on AWS, and you write the code for it, and then execute it for further when you need it on any of the new environment. So probably on production, you need to set up a new production 2 environment. So you just need to run the Terraform script, which makes things really efficient on your end also. With Ansible, you have playbooks. They work in a similar way. The only main thing they're used more is from a configuration perspective, and to provide updates on your for your systems as well when you're deploying it from time to time. Yeah, that brings us to something more related to monitoring. Uh, so there are monitoring and log management is more from an add-on. Initially, you may not need that much of a knowledge, but eventually you will look into all of these. In fact, writing filters on Grafana, Kibana, making sure that your CloudWatch is working fine, making sure that uh, there are no issues coming up. There are stuff like ping test, which allows you to make sure that stuff is online, and all these together kind of get you into monitoring things. These days, we've done a lot of integrations also with monitoring to different messaging systems like Slack, Teams, in order to make sure that everyone is alerted as soon as possible when it comes to issues and monitoring them. So that kind of helps your developers also to know, okay, this is where the issue is happening. Because once, say you the server goes down, or with probably if you have set up Sensu and Grafana on your server, at least you'll get an alert earlier on that okay, your CPU usage has gone to 90%, your temperature is high, and I'm going to shut down. That is what with the basic CPU will give you. But with Grafana and these tools, it will help you alert people around. And once that is the first phase of site reliability, and the second phase is quickly fixing it. So in order to quickly fix it, you need to know logs, or where are the logs. And ELK, which is nothing but elastic log, and Logstash and Kibana stack is very widely used to do that. So basic knowledge about that definitely helps in your DevOps journey. So I think I've covered most of the, what do you say, when you are starting a DevOps journey, what all would you need to cover in uh, uh, as a as anyone who is getting into DevOps in 2021? So I know the breadth is huge, but definitely having parts of it in DevOps, rather than becoming a king of one side of it. If you're a jack of all trades, then definitely you will outshine a lot of people, because you have to think on your toes and make sure that that happens, that it takes that you're quickly solving stuff for people, and making sure it's not an infra problem, and passing whatever information that the developer needs to fix ahead, and also alerting everyone at the same place. So that whole, if you want to get there eventually, this is the journey I feel you should follow. If you ask me what is the future of DevOps, automation and more automation, definitely. I had this pet project which I've sidelined, unfortunately, but I would love one day to just tell Alexa to spin up an EC2 server. There are already, I'm sure, Alexa skills to do that. But I was trying to build that on my own, but unfortunately, I've kept it as a pet. But bot-based deployments, bot-based alerting. We, in fact, recently saw a nice bot written on Slack for managing Kubernetes also. It's called KubeBot, I think. So all those will come into place. Easier integration and faster deployments will also uh, is a definite. I've seen the way. So initially, first time I have worked on Amazon AWS was back in 2012, when there were just three services, which was cloud compute. Second was S3, which is the storage side of it, and it was a huge thing that we had stored some, I think, few GB of data in S3, and we were using EC2 to get things out of it. So and showing it on an app. So that was back then, and we had to struggle even to get all those things put together. But now the way AWS, it happens with a lot of other languages and other IDEs also, uh, uh, is getting out more easier to use interfaces as well. So even with GCP, Firebase, there is a lot of development happening which will help integration as well as deployments and scaling, as well as getting things online way faster. And yeah, that also covers the never-ending improvement cloud infrastructure point. You have to be on your toes a bit to know what is coming. If there is something cheaper and more resilient, I would say definitely go that way. We we used to, so in the Coditas's containerization, or do you say history, we used to use a different service earlier on for hosting most of our containered application, which was called ECS, which was a stopgap from AWS for those who didn't want to go to Kubernetes but still wanted to work with containers. And now with a lot of our clients, we've really realized that with Kubernetes on the longer terms, it definitely gives a better cost effectiveness also. So all these come with the more you learn about it, and in fact the improvements on the cloud side as well. And like I said, we just begun. I would say DevOps is still it's matured, but it's still a long way to go before, I would say, and it's never going to end. So anything that you that will come up will definitely need uh, to be deployed somewhere, or definitely need some kind of infrastructure. And if you are in the DevOps practice, or a DevOps engineer, the possibilities are endless, I would say. Yeah. So I'm open to any questions we have.
Sure, Gaurav. Thank you. We'll take up some questions. We have first question from Nikhil. How do you bag an entry level job when you have experience in other domains and trying to make a switch?
Uh, I would say if I were interviewing someone who is switching, I would definitely look at the interest of the person in the new domain. And by interest, I would see more towards, again, I come back to the same thing, more towards how, what all have they experimented in the new domain. And that kind of as an interviewer definitely helps me know that okay, this guy is curious about the technology, is curious about going into more depths in that particular technology or domain, or for in this case if someone was shifting to DevOps, and to what depths has he learned, or on his own, in spite of being on a full-time job doing something else, what all has he or she learned on that front. So that kind of gives the idea, and definitely can, the more depth you have picked up on your own, the higher the chances you might be selected.
Right. Thank you, Gaurav. Then next we have a question from Ankit. Is DevOps a good career choice for a fresher if he or she is skilled in AWS and is learning DevOps?
Yes, definitely. We have a lot of we, in fact, every year now are building DevOps teams, and with freshers, with seniors as well. Make sure you get the right mentors. Make sure you're in for experimenting, and make sure that uh, learning or learning about a cloud is good, but getting hands-on on it is definitely a plus point as a fresher as well. And for that, you can use a lot of there is Google Cloud's free tier, sorry, AWS's free tier also, and other places also.
Okay, I think that has answered Ankit's question. Next, we have question coming in from Manali. How can a fresher start his or her career in DevOps?
I would say, as I've walked through the presentation, also start with basic Linux commands, then get on to uh, learning a bit about Docker, and then get on to learning a bit about AWS. And all in all three cases, all you need is a system. So uh, as a fresher also, you can just go ahead and try stuff out, and definitely you'll be able to pick it up. It's relatively simpler. Even if you don't have a programming mind, you need to know which command does what, more from that sense. And if you are able to visualize, okay, this triggers this, then definitely I would say you'll enjoy also picking up DevOps.
Sure. Okay, so we can take next question from Suraj. Suraj asks, which cloud service should I start with?
So a cloud service, I would say particularly start with EC2 or virtual machines on GCP, EC2 on AWS. Reason being that kind of gives you the first level, feel for having or knowing about infrastructure on the cloud. EC2's T2 Micro EC2 is free on Amazon for almost, I think, 90 days or more than that. A year if you don't, I think 72 hours if you don't use it at all and shut it down. On the GCP side, you have virtual machines, but then they have a $300 credit. So definitely, I would say either of them. You can launch a Linux server there and play with Linux commands as well. So that will definitely help you practice both sides of it. So uh, and get a hands on one of the cloud services as well.
Right. Okay. Next, we have another question from Suraj. How do I get hands on before actually working?
Again, Wizlabs. a Cloud Guru, and free tires from AWS, and credits from GCP. All of them are available. You just need to have a credit card or a, I think, Mastercard. It can be a debit card also. Just make sure, be very careful if you're trying it on the cloud to shut down servers which you have started, and not start something which has a tag of .large to it. So .large or .medium, because they cost, and suddenly you will stare at a bill which is like 20,000 rupees or 30,000 rupees. So be very careful on that front. But definitely there are free resources available. There are, in fact, Google and AWS, all of them, and Azure have different webinars also. And if you attend them, they do give extra credits, as well as for Viz Labs and other places as well, to for you to experiment and get hands on.
Right. Okay, next we have Rupesh asking how much time required to learn DevOps tech stack.
Time wise, I would say you can, if you're starting from scratch, in a in a, at least 3 months, you should be quite. If you are spending all the time on learning, 2 to 3 months is what you need to gain knowledge, basic knowledge on all aspects of DevOps. But it takes at least a couple of years to be a really good expert at it. So and years of being curious and enthusiasm also.
Okay, thank you. And lastly, we have Manjeet asking, we hear a lot about regulatory compliances in banking, healthcare, and other domain. What is your viewpoint and ways out as to include regulatory compliance and goals within DevOps practice?
I would say it's a must-have. Nowadays, with the amount of leaks, amount of data leaks, and so data is gold nowadays. So remember, as a DevOps engineer and as a person, you are one of the main responsible person to protect this gold. And so I have worked with companies which have been HIPAA compliant, which are PCI compliant. HIPAA takes it to a different level. So HIPAA is act in the US which avoids people, talking about their health issues to others. And what this implies on a DevOps side is your services also can't talk to each other for patient data. And the amount of security that we needed in that applications, and those applications, even we on the for example, on the mobile end also, we were making sure that the APK which is generated is tamper proof. So imagine what that percolates when it comes from on the server end and on that side. And similarly is the case for all security measures. In fact, recently at Coditas, we became SOC compliant, and which meant in all our cycles we needed to add few amounts of security measures as well. Um, uh, there are even at the code level, you do have certain tools like Sonar and other tests which allow you to detect vulnerabilities there. Plus, you definitely need. In fact, I am now planning to do a security certification for AWS eventually, but you definitely need few experts to look at your infra as well as what you've done inside it, to avoid getting compromised in any way. And I definitely give one of the highest importance to having security in your DevOps pipelines.
Okay. Thank you, Gaurav. I think we have covered almost all our questions. If by chance we have missed any questions, we have them with us. We will get back to you through our social media channels and emails. So, Gaurav, before we wrap up, is there anything you want to cover?
No, nothing. Uh,
Okay,
yep.
I think then we can close the session. We are good. So thank you everyone. We really appreciate you being here. You must have received a feedback link in the comments. Please help us know how did you like this session, and also join us on social media. We are on LinkedIn, Facebook, and YouTube, so that you get notified about our future events. So until the next webinar, take care, stay safe. Bye bye. Bye, Gaurav.
Thank you. Stay safe, everyone.